and we are going to study linear equation for linear equations. Of course, we are talking about the first order one, okay? So just call them linear because we don't have anything else. So that would be first order linear differential equation that we're going to do. Okay, a linear combination of y prime and 1. So this is the general form. Differential equation. So it's important to be able to recognize it. A differential equation of the form See, we have the dy dx, which is going to be y prime, plus a function, we call it p of x, times the y is equal to the other function, we call it q of x. This p of x and qx are going to be nice continuous function or differentiable function. And the y is missing part. We write it down in z by dx, but in prime form, if you like, or this is going to be y prime as px y equal to the q of x. We mostly work with the second one. So an equation of this form is going to be called, okay, it's going to be called a first order linear differential, okay, differential equation. That's your function. The point that you have to consider is the way I write it down. I write it down so that the coefficient of y prime is 1. You have to keep it 1 because the formula that we are going to produce depends on this coefficient. Okay, so if it's not going to be 1, not a big deal. We can divide it. If it's a 5y prime, you divide by 5. So this is just to notice. It's going to be the same when we get to the higher order. So let's have some examples first. Make sure you can identify it quickly. Okay. So the following equation are linear. Okay, with different notations that we're going to use. The following are linear equation. Okay, linear equation. The first one, very standard, dy dx as 2xy equal to the x. Simply this one. You have the y prime, something times y equal to the x. So this is linear. What is p of x?
Right.
Because we're going to use them. Note that p of x is 2x and the qx is x. So for each equation, you have to identify it. There's a formula that take care of it. Okay, this is one format. Any question? Second one, this is a little bit different. It's x dy dx minus 4y equal to the x to the 6 e to the x. And they give you the assumption that x is not equal to the 0. See if it's given to you, so your job is you divide by x first. When you divide by x, that will be the classic form of the linear equation. So you better do it right at the beginning. If you miss it, because you will end up with a complicated integral. So if you find uncomfortable, probably you miss this one. Okay, so there is x prime, xy prime, if you like, divide. So note that by dividing, because we have to have the standard form. Dividing by x. So it's going to be the conclusion. The conclusion is dy dx minus, this is the way we divide, 4 over x, y. And this is going to be, this is x to the 6th. You divide by x, that gives x to the 5th. X to the 5th, e to the x. So we divide both sides by x to normalize this coefficient, okay? The coefficient is going to be 1, and this is the way you divide this one, negative 4 over x. You divide the coefficient by x. And the other side, this is x to the 6th, make it with x to the 5th, okay? So the conclusion is going to be, what's a px now? Negative 4 over x. And the q of x would be x to the 5th, e to the x. It should carry that negative 1. Okay, that's 1. Any question? Another one. Just the notation will be different. Y prime plus 3x squared y equal to the x squared. It's a linear. You see, this is the y prime. Something times y equal to the x squared. So it's a linear. Again, note that e of x, it's going to be 3x squared. And the q of x is equal to the x squared. So the coefficient of the y prime is already 1, and you don't have to worry about it. Any question? So you will see various modeling, if you like, later on. It's going to be all linear. Any question? Yes.
So what is the point of the p and the p of the x and q of x? Is q of x the final answer?
No. This is just a notation.
Sorry?
No, this is just we compare it with the classic format that's given to you, we identify it.
Okay.
The reason is I'm going to make a formula to solve it. That formula depends on the p of x and q of x.
Okay, so
So that's, that's the one, just to remind you.
right,
This is the p of x, e of x. Because in order to solve it, you have to identify the p of x and q of x first.
it's kind of like Liate, where like you identify the VDU.
Yeah, that's good to know. You see in a minute, and I'm going to use it, okay? So this will tell you that on the other side, you should have a function of x. See, if on the other side, you get something like x squared times y. In that case, this is not going to be linear. Okay, so the one that you pick out must be a function of x, p of x, q of x. The only y that you will see is going to be when we get a px times y. Okay, now how are we going to solve it? You see, there are different ways to do this type of problems. It's linear equation. This is a method that we are going to see it here in short form, and later on we are going to, extend it to something else. So don't be surprised the way I'm going to do it. The idea is look at the term to the left. You see these terms to the left that you have, y prime 3x squared y, and on the other side we have x squared. So what we are going to be interested in, we are going to arrange this term to the left to be this one. I want to use like a method that we do for the separable equation. Separable equation was easy. It was through function on both sides, you integrate and you got it. So what we would like to do is we would like to make these, you see this one? You make this one as a differential of a function, if you like. You make this one as a z prime, if you like. If you can have this one to be a derivative of a function or y prime, and this is going to be just x, you can integrate it and then you're done. Since this is a kind of product over here, so what we have to do is we have to show that this is the derivative of a product of two functions. Because you have the y prime 3xy. So yeah, of course, this cannot be seen as is. You cannot guess what's going to be the function, what's going to be the product of those two functions. One of them, of course, is clear. One of them is y. You have to find the other one to get it. There is a technique that we're going to do it and we find it, something we call it integrating factor. But we don't have that integrating factor and we talk about this one right now. So that's why I suggested to you. I suggested to you a nice function. I give you a function that if you multiply both sides by that function that I'm giving to you, then automatically this term to the left here, this would be the derivative of a product of two functions. Derivative of the first times second plus derivative of a second times first. If this is going to be the product, derivative of product of two functions, you can call it z. It's like z prime. Then you can integrate both sides and then do that. So I'm going to give you the proof, but at the end, you get a formula. In your book, suggested that use that all the time, but you don't have to. As soon as we get the formula, I prove it for you, so you believe it. So we can use it, okay? So that's the idea. And we do this one in the next section quite a lot. We're creating something nice, that's something nice, something useful, we call it integrating factor. Integrating factor is a kind of, there is a function that if you multiply both sides of the differential equation by that function, then it can be solved. It would be changed into the kind of, if you've done calculus 3, some of you, it would be changed into the kind of those conservative force, etc., that we have, and we can do it right away. That's the idea of this proof. That's the best proof or best method to do it. Okay, so how are we going to solve it? I'm going to introduce that function for you, and then quickly we can do it. So solving, there you are, solving linear equations. Yeah, that's my suggestion. Suggestion is, so you give me the function, there you are, to solve this equation, the linear equation. This is the one. I'm going to call this one y prime plus p of x times the y equal to the q of x. So we already identified that it's a linear equation. And if the coefficient of the y prime is not 1, you already done it. So suggestion is this one. You see, multiply both sides of the equation, both sides, by this function, by the following function. Following function. It's called in future integrating factor. What is the function? It's going to be denoted by the notation that we use is mu, we call it mu. Right? Okay, then the statistic is like the main formula, mu, okay? You multiply both sides by the mu of x, the function, and this is the function, e to the integral of x dx. Remember, you already got the p of x. So as soon as you get the p of x, you find the integral of p of x, then you introduce the mu. So it's easy to find the mu. Now multiply to see what's going to be the result. Multiply both sides. Okay, you bring this one down and multiply. So what's going to be the, the result? So I have y prime. I multiply by mu. I write on mu in short. So it's going to be plus. I have the pxy. I multiply by mu. And over here, I've already got the q of x. I multiply by mu. Multiply by mu. Okay. So remember what I want to do. I want to make sure that this left side is the derivative of product of two functions. Okay, let's find out what is going to be mu prime. What is derivative of the mu? This is mu. What is mu prime? You see, it's exponential function. Derivative of exponential function is what? Exponential function, but you have to multiply by what? U prime. U prime, the top is integral of px dx. What is derivative of integral of px dx? Dx. So derivative of u prime is going to be what? U prime is going to be exponential function as is times the derivative of the top, derivative of u prime, which is going to be simply p of x. Okay, any question? But remember, what is this? This is just the mu. Okay, this is just the mu. So mu prime is equal to the p of x times it by mu. P of x times it by mu. So if you go back to your equation here, so what you have now? You have the y prime mu plus, so look at this one. You have the px mu. For the px mu, you replace the px mu by mu prime. So it's going to be plus y times mu prime is equal to the q of x times mu. Any question? So what I did, I just investigate the derivative of the mu function. Its exponential function never change. Just multiply by the u prime, if you like. U prime is p of x. So we check, find out that the derivative of mu is pxy, px times mu. Okay, so I just go back here and substitute. Now look at the term to the left, is exactly what I'm looking for. It's just a derivative of a product of two functions. See, derivative of the first times second, plus derivative of the second times first. So instead of this, I can write y times mu prime is equal to q of x times mu. Because when you prime it, you get the derivative of the first times second, y prime mu, plus the derivative of the second times first, mu prime y. Now I can integrate it. If you integrate both sides, this prime, you see, you integrate both sides. Integrate both sides. I write it down so that you know what's going on. It's a y mu prime dx. And this is going to be integral of qx. Okay, integral of qx times the mu dx. But over here, you just go antiderivative of the f prime over here, so that give you y times mu. And on the other side, you get the integral of a qx mu times dx. Remember, we are looking for y. So in order to get the y, we divide by mu. So y equal to 1 over mu. Okay, 1 over mu integral of qx times mu dx. That gives you the solution of the linear equation. Yes.
Why wouldn't the mu's cancel? Can you pull it out, or is that not allowed?
Mu is a mu function of x. You cannot put it out. That's one. The first one that you put it out because that was part of the differential. Okay, bad enough. You see, and that's it. So you can use this formula. You don't have to do it over and over in each problem. So you recognize the equation is linear. So you have to find the mu first. You find the integral of px dx, first. Then you find the mu. Then you have to form this integral of a qx times mu. Then you know it's most of the time it's easy integral. You may have to use integration by parts a couple of places. But otherwise, it's very easy method to solve a linear equation, okay? And this method, I just did it because there are going to be a couple of more in future, even some problems in your book, that we can use this type of methods to be able, to take care of our problems. But in the case of the linear equation, it's going to be very, okay. Okay, so this is going to be the general solution, of course. Where let's just conclude this one. Will you write it down? Okay, so the conclusion is going to be whatever what we did is this one, the general solution. The general solution of the linear equation. The linear equation, I repeat the format again, is a y prime plus pxy equal to the qx. Is given by the formula y equal to 1 over mu integral of qx times mu dx, where mu is e to the integral of px dx. That's it. When you integrate it to find the mu, you're just finding one mu. So there is no constant. And when you're integrating the last part, this is the solution of your equation. You are going to have a constant, okay? That's the way we do it. So we're going to give some examples. Maybe we are going to do it. We give you one of them in this common quiz, and there is one special one. So you are going to have 2 questions on the linear equations for this quiz. So far we get 3 questions. Okay, any question? Are you ready? Let's do it. Solve the equation. Very easy equation. When we are done with all of them, I'll give you the idea how you guess what solution are going to use. You see, separable one is very easy to find. If it's not going to be separable, you check the linear. If it's not going to be linear, that will be the next step that we're going to have. It has exactly the way we do it, and then we can identify. There you are. Solve each linear equation. Solve each equation or linear equation. First one, dy dx plus 2xy equal to this. Okay, equation is linear. You identify px and the qx. Solution. What's the px? P of x. 2x and the qx. X. That's step 1. Remember, if there is something here, you have to divide first, then identify the px and the qx. Okay. Now we want to find the mu. Okay. So you have to find the mu first. In order to get the mu, you need integral of a px dx. Integral of a px dx. It's going to be 2x dx. And that gives you 2x squared over 2, which is x squared. Remember, no constant c here, because this is not the solution of the equation. It's just finding out that one function you are looking for. Okay, so that gives you x squared. So mu, just remind you, this is the formula for the mu. So mu is e to the x squared. That's the step 1, find the mu. Now bring the formula and just get it. The formula y equal to the 1 over mu integral of qx times mu dx. Substitute is a 1 over mu is e to the x squared. E to the x squared integral of qx is x. X times mu e to the x squared dx. Okay, continue find that integral. You know that's exponential function, e to the x squared, u prime would be 2x. So you need only a 2 here to be able to take care of. So what I'm going to do, I'm going to just do it in the short form. So it's a 1 over e to the x squared. I divide the outside by 2 and I multiply the inside by 2 to create the u prime. Okay, so this is simply integral of e to the u, which is going to be e to the u plus c. Okay, you take this one to be u. Du would be 2x dx. That's why I divided by 2. So that is here. It's going to be 1 over 2e to the x squared times it by. The inside would be e to the x squared, e to the x squared plus the constant c. Okay, you multiply because you can simplify it. So if you multiply, it's going to be e to the x squared, 2e to the x squared, plus c over 2e to the x squared. So we cancel out. Okay, different way to write it down, you know. One is just simply this one, 1/2 plus c over 2e to the x squared. Some people like to move the bottom one up, write it down in the negative power, you know, it's up to you. For some people, they drop the second 2 and they embed it in constant c. You know, it's not going to be just anything that would bother us. Okay, that's the first one. Any question? So make sure to pick that p of x correctly. And if the coefficient of the y prime is not 1, normalize it, okay, to get these numbers. Some of these integrals are going to be a little bit more involved. So I give you a couple of them to see what you should look for when you're dealing with this integral. Otherwise, it's a nice equation. Let's see what is special about this second one. Ready? Second one. X dy dx minus 4y equal to x to the 6 e to the x. This is the case when x is not equal to this. Again, the equation is linear, but your extra job is quickly have to write it down in a standard form. When it's a standard form, you cannot have x here. So divide by x first. Okay, solution. Divide by x. Divide by x, that give you dy dx minus 4 over x y. And this is going to be x to the 5th, e to the x. That is going to be the case. So now it's a linear equation. Identify the px qx. So your p of x is a negative 4 over x. Q of x is x to the 5th, e to the x. So the missing part is mu. To find the mu, you need to find the integral of px dx first. Okay, so find integral of a px dx. It's a negative 4 over x dx. Any suggestion? What's this integral? We put out the negative 4 is 1 over x dx, which is the natural log. Okay, so it's a negative 4, 1 over x dx, which is going to be negative 4 ln of the absolute value of x, if you like. But you have to, we are going to simplify it further. So we move this 4 up because you have to find the e to the integral of px dx. So if you put the 4 up, that gives you ln of what? It's going to be ln of x, or absolute value of x to the -4. So it's going to be, because to the 4, then it's going to be x to the 4, but since it's a negative, it's going to be ln of 1 over x to the 4. So this would be the final answer. You got to be careful. These simplification are important. If you miss that negative sign, the resultant integral would be very complicated. Okay, I move it, yes.
Does the E and the ln cancel out or? is it-
Later,
Okay.
yeah. That's why we prepare it. We prepare this one because we know that we are going to eat, okay? Then I will cancel. Otherwise, you have to do it later on. It doesn't matter. Okay, so now we go for the mu. Mu is e to the integral of the px dx. Now it's going to be e to the ln of 1 over x to the 4. And you know that the e function and the natural log are inverse of each other. So they will cancel out. The result would be 1 over x to the 4. So the integrating factor mu is 1 over x to the 4. Any question? So be careful about these type of operations. Now we are ready to propose the solution. So the solution is y equal to the 1 over mu integral of qx times mu dx. 1 over mu would be 1 over x to the 4. And qx, remember qx was x to the 5th e to the x. X to the 5th e to the x. Times a mu, and the mu is 1 over x to the 4. Dx. Simplify. You see that's going to be, so the y is going to be equal to, use the reciprocal over here, you move the x to the 4 to the top, it's going to be x to the 4. Integral of, what's the leftover? X e to the x dx. Now you have to find this integral to get these numbers, okay? So I'm going to find this integral separately. You know that you have to use the integration by parts, or use those shortcuts that we need quite a lot in this course. Okay, you know that those top Taylor method, if you remember it from calculus 2, if you haven't done it, you're going to get practice on this one. This is the way we do it. We can do it now. This is easy. Integration by parts give you the result right away. But using these tables, the first column is going to be sine. The second column we differentiate. The last column we integrate. It's like the u dv that we did. The sine, we start with the positive sign. We let the x to be u, if you like. And the ex is going to be your dv. On the first column, you differentiate to get to the 0. In the second column, you integrate. So the next sign is going to be positive, negative, it's going to be negative. The derivative of x would be 1. Integral of e to the x is just e to the x. We continue again, the negative sign would be positive. The derivative of 1 would be 0. Integral of e to the x is e to the x. Then the answer would be collected by multiplying these together. So integral of x e to the x dx is going to be equal to the x e to the x, okay, minus e to the x, and the constancy that we have. Okay. If you haven't seen it again, you are going to use it quite a lot. Okay. Is there anybody who haven't seen this one?
I've never seen that.
Never seen it.
Okay, now you see it.
This is integration by parts.
Yes, in short form. It's called a lazy student integration by part. There is an article related to this one. No, the way we do it, yes.
Sorry, do you know like the actual formula where it's like u du?
Yeah, it's the same one.
It's the same, okay.
Yeah, but you know, because this is x dx with the actual u dv, it's easy. And it's going to be x to the 5th. You know that you have to go with the, you know,
For each one.
5 times. That's why we need this one, especially when it's coming with the sine and a cosine. Okay, let me just explain it once if you haven't seen it before.
What's up, Dave?
You see, these are just the UDV that we did. We create this column on the first part, because it's positive, negative, positive, negative. In the second column, it must be a power of x. This can be done if you get x squared to the fifth to the sixth. In the second part, it's just that dv that you write, e to the x. In the first column, you are going to differentiate it so that you get to the zero at the end. This is where you stop. In the in the last column, you integrate. So it's like the way you do it, you know, u times v minus integral v du. Okay, and you continue. So I just differentiated, that give me 1, the sign is negative, I integrate into the x, which is e to the x. I continue to get the 0. Then you cross multiply to get these results. It would be very useful if you were given x to the fifth sine of the 5x. Okay, so we're going to use it. In future, some of the Laplace transform, if you want to find it, we use this method. Yes.
How do you know what sign to start off with? Is it always positive or?
Yeah, it's always alternatively positive, negative, positive, positive.
But you always start with positive though?
Yeah, yeah.
Okay.
It's like when you do the actual substitution method, it's a minus 1. Yes.
And then the tabular method, is it only valid when you, when you're,
Yeah, it must be powers
Differentiation
of
goes to
x.
0?
Yeah,
has to go to 0, correct?
yeah, otherwise you can do it. You can do it for some other purposes, but there's a small art, I can post it for you. It's a nice, especially it's going to be so useful for us, so useful. Okay, I'm not done, but let me just finish it. You substitute to get it, okay? You have to go back. Don't forget the x to the 4th here. So y would be x to the 4 times z prime. X, e to the x, minus e to the x, plus. Okay, then you can distribute it to get the final. So the final answer is this one, x to the 5th, e to the x to the 4th, e to the x, c, x to the 4th. So that give you the final